All right, so new chapter. It's exciting, isn't it? Always feels like a fresh start when you do a new chapter. So first thing we're going to do, let's just talk about this. Okay, we're going to talk about the area of stuff. I'm sure at some point in your math career, your math teachers talked about area. Have they? Yeah, what was the easiest thing about area that you learned? Do you remember? What was it? Finding the area of a what? There's a big hint right there. A rectangle. Yeah, it's pretty easy. So you could have done this. Oh, let me click off of it first. So you could break this down into a bunch of squares. I'm just kind of eyeballing this, so it may not be perfect, but it'll be kind of close. Maybe put one right down the middle. Yeah, it looks pretty close for eyeballing it. All right, so there is a rectangle. So what does it mean to find the area of something, of anything? Okay, it doesn't matter what shape it is. If you're finding the area of it, what you're trying to find is how many squares can fit inside of that object. Okay, we're going to do more than just a rectangle. All right, as you can see right here, we're going to do parallelograms and triangles. And I believe there's a whole entire chapter in this book on area of a whole bunch of other stuff. I don't think we get to that chapter because we're pretty close to where we were last year, and we didn't get to it last year. So I doubt we'll get it to this year. So this will probably be one of the very few. This whole chapter is not about area, though, is it? What's the title of this chapter? Is it called area? So maybe this is the chapter where we're going to do all the areas. Oh, it's not in this book. See, my answer book only is half of the book, and it stops at chapter 6. So I have to find out where I put my other answer book. And I don't know where it is right now, but it's somewhere. But anyway, okay, so this is the chapter on area then. All right, so I guess we will do it. So let's talk about what this is. So I did a rectangle, all right? It has, now you could call this base and height. Some people call it that. But most of the time when we do a rectangle, we usually say that this is the, we say this is the length, right, from here to here. And then from here to here is the what? What do you think we call that? The width. You've heard that before, haven't you? All right. And the area, when they tell you the area, what is it? It's the length times the width, right? But what are you really doing? You're finding out how many rectangles you had. So if I wanted to count them up, I could just count 1, 2, 3, 4, 5, 6, 7, 8. I could do that, couldn't I? But how many do I have across the bottom here? If each one of these is 1, so that whole thing would be what? 4, would you agree? And what would it be right here? That length and that length. Again, this is a 1 by 1 square in all of these. And so what is the width then? It's what? It's 2. Do you remember if you have a whole bunch of things, do you have to add up all of them? Do you have to go 1, 2, 3, 4, 5, 6, 7, 8? Nope, you could just do what? How many across? Actually, how many across? 4. How many up and down? 2. So I got 2 rows of 4, don't I? And so what do I do with that? Just multiply them together, right? So I got an 8. So that's how you find the area of a rectangle. It's just the length times the width. Sometimes you might see B times H. What do you think that means? Base and the height, okay? So you could call it base times height. Or, again, like I said, when you first learn how to do area of a rectangle, they usually call it length times width. Pretty simple, isn't it? Yeah. What if you had a square? Well, square is a rectangle, isn't it? Do you agree? Yeah. So you could break this up into a whole bunch of different ones. So, again, I'm just eyeballing this. It may not come out perfect, but that's okay. Yeah, that one's a little bit wider than that one, but you get the idea. All right, let's go right here. Let's go right here. Let's go right here. All right, so there we go. Pretty close. Not perfect, but that's okay. So this is a square. Square means all the sides are the same, right? So my length doesn't, by the way, I should have mentioned this. Does the length always have to be across the bottom? Does the length always have to be the longest one? No, it doesn't matter. I could have called this one the length, or I could have called it the width. It doesn't make any difference. Everybody with me? Got a lot of people, their heads not looking up here. So I could have called this the length or the width. I could have called this the length or the width. It doesn't matter. You just take one side, multiply it by the other side, the side that's not across from it. Everybody see that? So you're not going to multiply this side down here times this side up here. You find the two different sides, multiply them together, and you got the area. Pretty simple. On this one, look, this side and the one that's next to it right here is going to be the same. Why is it going to be the same? Because the thing is what? It's a square, right? So all four sides are equal to each other. So you could go length times width, but sometimes they do this. They call this S, and they call that S. Why do you think they call that S? S for side. Good. Okay, so this is one of the sides. In fact, all four of these sides would be the same because it's a square, all right? So a lot of times you'll see this. I probably will not write it like this. You could also think of this as length and width and just go length times width or base times height. It doesn't make any difference. But they do this in the book, so I figured I'd show it to you. A lot of times they'll do this. The area is equal to the sides. What? Side times side. But what is a side times side? Side squared. Very good. Everybody see that? That's the same thing as base times height, length times width, side times side. But we simplify it. Side times side is what? Side squared. We getting that? Yeah, so that's another formula, I guess. You didn't really need that formula, but sometimes it's a little bit quicker, right? You just take a look at the side, you take that number, and you square it. So that kind of looks like a 5. Let's make it a 5. All right, so that's a 5, and that's a 5. Then what's the area of that rectangle, or that square right there? What is it? It's 5 squared, which is 25. Now, we measure things. In order to measure something, we need some kind of unit of measure, don't we? All right, so let's just, what's your, I don't know, if you have a favorite, probably not. It's kind of a joke question, but what's your favorite unit of measurement? Feet? Okay, so we'll say that's 5 feet. We'll say that's 5 feet. So it's very important that you put your units. If they give you something in units, all right, in feet, inches, centimeters, meters, kilometers, whatever it is, then you need to use them and put them in your answer. Yes? Because I'm showing you how, well, I put 5, didn't I? That was kind of dumb because I don't have 5. I don't know. I was just thinking of a number. At first it worked when it was just S, right? But this is how many squares. Let's actually put the number that we have in there. I didn't even think about that. Yeah. So this is like, this is a 1 by 1. See, that's 1, whatever it is, feet. And this right here is 1 foot, okay? So what is it all the way across? 4 feet. What is it all the way up and down? 4 feet, okay? Because that's a 1, 1, 1, 1. Okay, sorry about that. So let's use 4 instead of 5. Is that okay? Yeah. So what are we going to do? We're going to go 4 feet. And what are we doing? We're going to square it, correct? Or you could go 4 feet times 4 feet, however you want to do it. Same thing. What's 4 squared? 16. Now, this is very important. You also got to square the units, okay? They give it to you in feet. So it's feet what? Feet squared. So we write feet squared. That's how we write it, okay? So when it's an area, it's always feet squared or inches squared, centimeters squared, meters squared. Everybody with me on that? So that's how you need to write the units. Don't just put 16 feet. That is not a unit of measurement for area. Right? Area has to be something squared. Even on a rectangle, like up here. Let's go back and do this one. We didn't actually do the math on this. So what is the area of a rectangle? Let's call this centimeters. We'll just change it up. We'll go metric. All right, so what do we got? We got 4 centimeters times what? 2 centimeters. What does that give us? Is it 8 centimeters? 8 centimeters squared, because centimeters times centimeters is what? Centimeters squared. So that is how you would write your answer for this. Okay? What's it really saying? It's saying we have 8 squares, right? And each of the squares is 1 centimeter by 1 centimeter. All right, that's what it's saying. Down here, what is it? What is your answer telling you? It's telling you got how many squares? You got 16 of them, right? 4, 8, 12, 16. So you got 16 squares, and they're all feet, 1 foot by 1 foot, so it's 16 feet squared. Sometimes you'll see this. I don't know. You ever get carpet in your house? New carpet? If you ever go to the store with your parents or something, and you're finding, like, even if you go to get some wood, buy some wood, you're doing a woodworking project at your house, and your dad's doing something like that, you'll see, especially like if it's a big panel of wood, like a, what do you call that? You put on your floor and stuff. Oh my gosh, it's a simple thing. Anybody, plywood. Everybody heard of plywood? All right, it's not real thick, usually about that thick. And then, you lay it down on your floor, you can walk on it and stuff. It's plywood. So a lot of times you'll see it measured in feet squared, all right? But in the store, you might see this. You might see 16, and then you'll see an SQ, and then you'll see the feet. What is that? What's the SQ? Square feet, okay? You've probably seen that before, right? How many square feet is your house? How many square feet? People talk about that all the time. All right, square miles. You ever hear that? Wow, I got this farm, it's this many square miles, or my state is this many square miles. Okay, you'll see that a lot. Sometimes you'll see it written like this, square feet. But in a math class, we're going to write it like this. We're not going to put the SQ, all right, for square. We're going to write it like this. Is that okay? All right, but out in the world, you might see it written like that. It means the same thing. It means the same thing as this. But a lot of people will write the SQ, or they might write the word square feet in front of it. Okay? Just so that you don't get confused. We good with that? Here's another thing. When I talked about, remember I said we could call this base times height? When I talk about base and height, if this is considered the base and this is considered the height, remember, this is a square. What kind of angle do we have if that's a square? A right angle. So the base and the height always have to make a right angle, or the base and the height always have to be what to each other? What is it? Perpendicular, okay? So if I talk about a base and I talk about a height, all right, they have to be perpendicular. They have to make a what? A right angle. You okay with that? All right. You're going to see in the next thing, I'm not going to do it today, we'll finish it up tomorrow. I just want to do rectangle today. But you'll see in the next thing we do with a parallelogram and with a triangle, you got to make sure, it's very, very important. If you're going to use base and height, the base and height have to be perpendicular to each other. Same thing with length and width. Speak up, I can't hear you. With an honors class, probably would, okay? So let's say yes. If I'm nice and forget about it, then you get away with it, all right? But it's so important. It's so important. There's a lot of teachers who tell you flat out, absolutely, if you don't put the right units on there, I'm marking it wrong. I don't care how much work it took to get your answer. If you don't put the units there, it's wrong. Sometimes I'm kind of a softy a little bit. Let it go. I might write it on there. You need to write the units or something like that, okay? So right now, I'm saying yes. All right? So make sure you have units. It's super, super important. All right? They give you an example, but it's really no different than, I got a couple minutes. Might as well just do it. I mean, it's really no different than what we've been doing. So here's the question. It says, find the area of a rectangle with this. So they actually draw the picture for you. And they ask you to find the area. Super easy, all right? It's not hard at all. One of the easier things that we've done all year. Would you agree? Yes. Okay, so if I asked you to find the area of this, what would you do? Yeah. Here's what I would do, though. I would go 3 inches times what? 5 inches. Now, the reason I do that is so you don't forget your units, okay? A lot of people just go, oh, 3 times 15, or 3 times 5 is 15. Boom, my answer is 15. But is your answer 15? No, it's 15 what? Inches squared, because inches times inches is inches squared. That's super important. I'm trying to lay a groundwork for you because in my other school I taught physics for a bunch of years, a whole bunch of years, like 15 years I think I taught physics, maybe more than that. And units were extremely, extremely important when you do physics, okay? So I'm just trying to lay the groundwork for you to get used to always putting the units. If they put the units, put the correct units, make sure it's not just 15 inches, make sure it's squared and all that. Later on, we do volume. Again, I think maybe that's the chapter I was thinking we were going to skip. Okay, we probably won't do volume just because I got so many other things I want to teach on. I want to definitely teach some trig by the end of the year, so I usually skip the volume chapter. I have taught that in the past, but in this book, it happens too late, so I don't do it. So you just got to make sure you have the correct units. It's really, really important, okay? So put them in there. Don't give me any reason to mark it wrong. Everybody got that? Okay, did I warn you enough? Yes, okay, good. All right, so tomorrow we're going to talk about parallelograms and we're going to talk about triangles. Parallelograms, similar to this, same thing with triangles, okay? Very similar, little different, okay? But if you understand the rectangle part, parallelograms, triangles shouldn't be a big deal. All right. Oh, you want the lesson plans up there? Yeah, I'll put them up there. All right, that's it for today.